Let's go ahead and take a look at the Unit 3 quiz here. There are 15 questions. We're going to go through all the questions. I'm also going to post pictures of them as well. Number one says here, which of the following is not true? Okay, so that's the key part here, not true. Of a projectile launched from the ground at an angle. Okay, the horizontal velocity is constant. Well, that's true. Okay. Let's look at the next one. The vertical acceleration is upward during the first half of the flight and downwards during the second half of the flight. The vertical acceleration? Isn't acceleration vertically always pulling down, no matter what, whether it's going up or down? So that's false. Let's keep going just in case. The horizontal acceleration is 0. Was there an acceleration whenever we go up with when we have a projectile? When we're talking about, this is the X component, and that is the Y component. When we do the X and the Y component, we only have acceleration on the Y. Do we have an acceleration on the X? No. Why? Because there is no acceleration. That is going to be true. Okay? The vertical velocity is 0 at the maximum height. Here's the maximum height. We call it non-zero acceleration. Velocity, though, is 0. The vertical velocity is 0. Yes, that is true. The only one that is false was this one right here. Letter B. Okay, let's keep going. Number 2. A projectile is launched horizontally from the edge of a 20-meter high cliff with the velocity or the speed of 10 meters per second. What is the horizontal distance a projectile travels before striking the level ground below the cliff? Okay, so projectiles launch horizontally from an edge that's 20 meters high. This from here to here is 20 meters. It says here with the speed of, so here's my cliff, here's my projectile. It's going to have a velocity of 10 meters per second. It's going to produce a parabola shape, right? And it's going to launch. What is the horizontal distance from here to here? Is my question mark. Okay? So in this case, then, I'm going to do my X and my Y components. DTV, DTVI, right? We can do a VF, but it's not given to us. VI we know is 0, and A is 9.81. Yes, it's truly negative because it's going downwards. I'm looking for the horizontal distance, so here's my question. This one is 20. T was never given to me. This is 10, and T was never given to me. I'm looking for the X component side. That's the side I'm looking for. But I do not have enough information. That means that this is a two-step problem. I need to come over here to the Y component, solve for T, plug it in over here, and then I can solve for my X. Let's go ahead and do that. I'm going to go ahead and call this number 1 because it's a two-step problem. D equals 1/2 AT squared. 9.81 times T squared. Divided by 4.905. That cancels. Divided by 4.905. Ready? 20 divided by 4.905. T squared comes out to 4.0775. That's not my answer. I need to square root it. So let's do that. Square root 4.0775. Oops. 4.0775. T equals 2.1, oh 2. Now I'm going to go ahead and plug that in here. 2.02. Now I can do part 2, which is D equals V times T. Okay. So in this case, D is unknown. V is 10. T is 2.02. So 10 times 2.02 comes out to 20.2. Is there an answer that's near this? 20.2? Yes, there is. I will say here, what is the horizontal distance a projectile travels? This is a horizontal distance, so there is going to be no negative with it, right? Negative could be this way because it's falling vertically downwards, but there is no negative here. This is a positive value. The correct answer is 20.19 meters, okay? And it's a positive number, not a negative. That's the reason why it's positive, not negative. All right, let's keep going. When a projectile is launched, the velocity may be described as constant in the vertical direction, right? When my projectile is launched, the x component horizontally is going to be the same number no matter what, all the way through y. We say this because there is no other vectors that are affecting it. There's nothing, we're assuming that there's no air resistance. We're also assuming that there's no gust of wind that's going against it or with it. So in that case, this number is going to stay the same all the way throughout horizontally. Let's look at the next one here. You have this picture to go along with it. A ball is rolled across the level surface of a desk, which is 0.9 meters high at a speed of 3 meters per second. They gave us a distance here. They told us here's the velocity. A target is placed actually 0.75 meters away from the desk. So at this location is where the target is placed. At approximately the height of, so here's the height of 0.59, a target was placed to ensure that it would contact with this ball. So this location, when it was going to make this parabola, because when it fell off, we were going to have it hit here instead of waiting for it to hit the ground. What is the horizontal velocity when the ball makes contact with the target? One more time, we just had this question. The horizontal velocity is constant. Oh, I'm sorry. Let's go back. Hold on, my brain is thinking for a second now. When a projectile is launched, the velocity may be described as constant in a vertical direction, decreasing in the horizontal, increasing in the horizontal, and constant in the horizontal. Correct answer here is constant in the horizontal direction. Okay, I will go back and double check those quizzes because I just saw that there's a, I'm sorry that I made this mistake right here. Okay, but constant in the horizontal direction, which is what I just said here. I guess I maybe just saw this vertical, but it really should have been horizontal. Going back over here, if this is constant in the horizontal direction, which is this way, as long as my object's in the projectile going through the air, then if this is 3 meters per second horizontally, at this location, wouldn't it horizontally be 3 meters per second? And at this location, wouldn't it horizontally be 3 meters per second? And at this location, wouldn't it horizontally be 3 meters per second? So what is the horizontal velocity when the ball makes contact with the target? Would it be 3 meters per second? No math was needed. Okay, let's turn the page so we can keep going. Next one here. Let me scoot over. While flying due east at 130 kilometers per hour, an airplane is also carried north 50 kilometers per hour by the wind. Find only the angle of the resultant velocity of this airplane. Do not add the degree symbol. Okay, let's go ahead and draw this out. What's going on? While flying due east, 130. An airplane is also carried north 50. Find the angle of the resultant velocity. So here's my airplane. And that's a resultant there. That's the direction that it's going to fly. Now, when I actually do my drawing, what did I say at the tail end of the drawing? That is going to be your theta right there. We want to find the angle here of the resultant from this airplane. That is my unknown. I have two legs. I'm looking for the angle. I have to use SOHCAHTOA. SOHCAHTOA. What's the next step? The next step would be, hopefully you found this is my right angle. So if I draw an arrow, this is my hypotenuse, this is my adjacent, and that's my opposite. What two legs do I have? I have the A and I have the O. So the A and the O is going to be the tan. So the tan of the theta equals the O over the A. Or the tan of the theta equals 50 divided by 130. So let's go ahead and do that first. 50 divided by 130 comes out to 0.3846. Now, that's not my angle. When I'm looking for the angle, I have to come over here and I have to do the inverse, which is the opposite of it. Like square and square root are opposites of each other. I have to do that. So in that case, I'm going to go ahead and clear out. I'm going to hit the second key first. Tan 0.3846, close parentheses. My angle is 21.04 degrees. It said do not add the degrees symbol. But there goes my answer. 21.04. Some of us maybe got 21.05, 21.06. Okay, but that's the answer. Why maybe you got 21.05? Because you went out more digits here. Maybe that's the case. Next one, number 6. A hiker travels 10 kilometers north and then 3.5 kilometers west. What is the magnitude only? What does the word magnitude only mean? Number. Of the hiker's resultant displacement. So the hiker went north 10 kilometers and then west 3.5 kilometers. What is the magnitude only? We are looking for this line right here. I don't know about you, but when I look at this, I see a squared plus b squared equals c squared. Or 10 squared plus 3.5 squared equals c squared. Right? 3.5 times 3.5 is 12.25. That's not my answer because this is square. So let me put c squared. Got to do the opposite, and I have to square root it. So C comes out to something like 10.59. Wait a minute. Use the correct SI units. Kilometers. Let's keep going. Next one, number 7, is the true or false. The horizontal motion of a projectile is independent of the vertical motion. Absolutely true. Absolutely true. We just said that twice on the previous page. Let's keep going. Number 8. A ball tossed vertically upward rises, reaches the highest point, and then falls back to its starting point. During this time of the acceleration of the ball is always directed downward. Right? Isn't gravity negative 9.81 always pointing down? Directed downward. Let's look at the next one. Number 9. A 65-meter rope that is connected to the top of the building. It is attached to the ground 50 meters away from the building. What is the angle does this rope make with the ground? Okay, so one more time. A 65-meter rope is connected to the top of a building. Well, I'm going to go ahead and here's my ground. Let me draw my building. Right. There it is. Now I've got a rope. It's attached to the top of this building, and they tell me that it's 65 meters in length. They also told me that it's attached to the ground that's 50 meters from the building. So from here to here, that distance is 50 meters. Again, I'm hoping you're doing your drawings. That's really going to help you out. Okay? As I look through y'all's homework, many of y'all are not doing y'all's drawings. Okay? I'm sorry if you feel like that's maybe just, childish or, it's not going to be helpful. But I don't know about you, but I've been able to do all of my math problems. But again, though, drawings have helped me out. So I would suggest doing the drawings. What is the angle does this rope make to the ground? This is where my theta is going to be located, not up here. This is the ground, and what is the angle to the ground? I'm going to put a question mark. I have 2 legs. I'm looking for a theta. I cannot use a squared plus b squared. I'm going to have to SOHCAHTOA this. So let's write that in. SOHCAHTOA. What is the next step of the SOHCAHTOA that I told you? I would go and find my right angle, draw my arrow. This is my hypotenuse leg. My theta and right angle is always my adjacent, and then I have my opposite. I'm going to grab my highlighter. I have this side and I have this leg. What are those 2 legs? The H and the A. Who is H and A? Cosine. So the cosine of the theta equals the adjacent leg over the hypotenuse. That is how we're going to solve for this. Or the cosine of the theta equals 50 over 65. Let's go ahead and do that. 50 over 65. 0.76923. Okay. Now, did some of you remember to make sure that your calculator was in degrees and not radians? How do you do that? You come over here to the mode button. And I can see that my calculator is highlighted in degrees. If it's not, I can go down and go sideways. I can hit enter. Now it's flashing, and then I hit clear. Just as a reminder, some of us may have forgotten to make sure that our calculator is in degrees. Let's go back over here. Now, I've got the cosine of the theta equals that. That is not my correct answer. This is kind of like the square and the square root. I have to do the opposite. So the opposite of a theta is the inverse of the theta, that -1. So I'm going to come over here, clear my calculator. I'm going to click the second key up here, and then a cosine, which is right here, 0.76923, close parentheses, equals, this theta is a 39.72 degrees. Okay, 39.72 degrees, and it said do not add the degree sign. Alrighty, let's keep going. Next one here, number 10. A projectile was shot from the ground and has an initial velocity of 5 meters per second and an initial vertical velocity of 3 meters per second upwards. What is the angle of the projectile fired? Okay, Here's my ground. I have a projectile that was fired into the air. Hopefully we all agree it's going to make a parabola. Now they told me that it has a velocity that's horizontal velocity, which is this direction, of 5 meters per second. And an initial vertical velocity of 3 meters per second upwards. What is the angle this projectile was fired? Do you see a right triangle right here? We're looking right here. What is this theta? First step, let's go ahead and label our legs. This leg right here is my hypotenuse, my adjacent, and my opposite leg. I have two legs. I have this leg and I have this leg. What am I going to do? I'm going to SOHCAHTOA this. SOHCAHTOA. I have the A and the O, which is the tan. So the tan of the theta equals the O over the A, or the tan of the theta equals the 3 over the 5. Here, 3 divided by 5 equals 0.6. Not my answer. I have to do the opposite of this, which is the inverse. So second key tan of 0.6 equals, the theta equals 30.96 degrees. Let's keep going. Number 11. From a horizontal distance of 80 meters, the angle of elevation to the top of a flagpole is 18 degrees. Here's the ground. Here's some kind of flagpole. From a horizontal distance of 80 meters, the angle of elevation to the top of the flagpole is 18 degrees. Calculate the height of the flagpole. What do I see? I see a right triangle. I see that I have one leg. I'm looking for another leg, and they gave me a theta. So let's go ahead first. Figure out my hypotenuse, adjacent, my opposite. I have my adjacent leg, and I'm looking for my opposite leg. I'm going to SOHCAHTOA this, SOHCAHTOA. I need the A and the O, which is going to be the tan, or the tan of the theta equals the O over the A. The tan of 18 degrees equals the O over 80. We're going to use our basic algebra to solve for this. Multiply this side by 80. That cancels. Multiply this side by 80. The opposite leg, or the height of the flagpole. First, I'm going to get tan of 18 degrees equals 0.3249. Multiply that by 80. 25.99. It says use your correct SI units. This is meters tall. Some of us rounded to 26 meters. That works too. Let's keep going. What is the acceleration of gravity here on Earth? Well, negative 9.81 meters per second square. Make sure you include your SI units. A person is flying a kite, has released 176 meters of string. The string makes a 27-degree angle to the ground. How high is this kite? Okay, here's the ground. Here's the kite up here. The string. How tall is the kite up in the air? That's my question mark. The angle is 27 degrees. and the string is 176 meters. Oops. All right. Well, I'm going to SOHCAHTOA this. SOHCAHTOA. And I see that this leg is my unknown and this leg I have. So I'm going to say, here's my right triangle. Draw an arrow to the opposite side. That's my hypotenuse, my adjacent, and my opposite. My H and my O is what I have, which is going to be my sine. So the sine of the theta equals O over H, or the sine of 27 degrees equals O over, that's an H, sorry, 176. Let's use our algebra. If I multiply this side by 176, that cancels. Multiply this side by 176. I'm going to come over here, turn on my calculator. The sine of 27 degrees equals 0.45399. And I'm going to multiply that by 176. So my O leg, or how tall up, it is 79.90 meters tall. All right, let's keep going. Next part over here is going to be true and false. First part here, a projectile does not have a horizontal velocity. False. A projectile with a rightward component of motion will have a rightward component of acceleration. False. Next one, horizontal velocity of a projectile changes by 9.81 meters per second. False. Horizontal? No, vertical, not horizontal. A projectile with a horizontal component of motion will have a constant horizontal velocity. True, absolutely. The horizontal velocity of a projectile is 0 meters per second at the peak. The horizontal velocity? No, false. The horizontal velocity of a projectile is unaffected by the vertical velocity. These two components are independent of each other. True. As a projectile rises towards the peak of a trajectory, the horizontal velocity will decrease. What? No. Just that alone is false. That makes it false. A projectile is a free-falling object. True. Turn the page. A projectile must be moving in the downward direction. False. What about when you toss an object up? That's moving in the upward direction. And then it does move downward. Next one. A projectile has an acceleration in the downward direction. True. The next one. A projectile does not have to have a horizontal motion. True. What if I just drop it? A falling skydiver with an open parachute is in free fall. False. It has the parachute to slow it down. A vector quantity always has a direction associated with it. True. Next one. A scalar quantity can have a direction associated with it. No, a scalar does not have direction. The next one. Vectors can be represented by an arrow. The length of the arrow represents the vector's magnitude, and the direction it points represents the vector's direction. All of that is true. The last one here. What is the acceleration of gravity on Jupiter if Jupiter is 2.5 times larger than Earth? Well, if Earth is 9.81 and Jupiter is 2.5 times larger, then we're going to go ahead, come over here, 9.81, multiply by 2.5, 24.525. Wait a minute. We're talking about gravity, so it should be negative. Correct answer? Negative 24.53 meters per second square. That goes my correct answer. Alrighty. So, other than that, I went through every single question. I explained it, went over it, showed you on the calculator as well. I will go over it in class. I'm going to take pictures of it as well. So please go back and watch it. It might be helpful. Have a good day.